Welcome to this lecture. My name is Mark Scythian. The date today is August 29th, 2025. So this lecture is going to focus on 8 sections of a square and each section's area expressed in fraction and or radical units rather than decimals. So you might have a geometry problem that requires you to express the answers other than decimal answers. So we'll assume you have a 45 square inch square and you find the areas of triangles A through H. So you take the square root of 45, of course, and if it were a decimal answer, it would be 6.708 inches by 6.708 inches square. So it's pretty straightforward. But instead of calculating the decimal answer, you can use the rules for radicals and just find a perfect square that is divisible into 45. So if we took 3 and we squared 3, we would get 9, then times 5. We can ignore the square root radical symbol. So then if we test it, 3 radical 5 becomes 6.708. So we know that is a 3 radical 5 inch by 3 radical 5 square. So if we isolated, let's say, triangle G, we know that the symmetry of the triangles is such that at least on the corner it is bisecting a 90-degree angle into two 45-degree angles at these corners here. So this can be a reliable triangle to extract for analysis. So the adjacent leg in this case is half of the 3 radical 5 width, so 3 radical 5 over 2, and then we know this is 45-degree angle, and we find the opposite side, and then of course we have the diagonal connector, that's the hypotenuse, and then the 3 radical 5 divided by 2, or 3.354 inches, is the adjacent. So tangent is opposite over adjacent, whereas sine is opposite over hypotenuse, and cosine is adjacent over hypotenuse. So we can use tangent and just find the tangent of 45 made equal to the opposite leg divided into the adjacent, in this case 3.354 inches. So if we solve for the opposite, it's just the tangent of 45 degrees times the adjacent leg length of 3.354 inches. So we get a equality across the opposite and adjacent leg. So those of you astute in trig, you'd know that right away. But just to prove the point, we know that we have equal opposite and adjacent legs at this 45-degree right triangle. So if we just simply multiply the base times the height divided by 2, we know each triangle has an area of 5.625 square inches. But however, that answer is unacceptable. We have to express the final answer in fractions and or square root radical functions. So we can take 3 radical 5 divided by 2 times itself squared and then times 1/2. So if we simplify this, we simply could focus on the 3 radical 5 over 2 squared quantity. So this becomes 3 squared 9 radical 5 squared is 5 over 4 times 1/2. So this becomes, if we focus just on the first fraction, 45 fourths. So if we made that a mixed fraction, it would be 11 and 1/4, because 11 times 4 is 44, plus 1 is 45, so 45 fourths. Then times 1/2, so we have 45 eighths. So if we check that it's 5.625 square inches, so that's correct. So then we try to reduce it further so we get the correct answers. See if we can go down any farther. So 1/8 times 3 radical 5 just becomes 3 radical 5 over 8. So that's our final answer. So because we're symmetrically dividing up the square into 8 sections, right triangles from 90-degree edges, we have an equality in the area. So 3 radical 5 over 8 square inches per triangle. And then final check is we multiply that value 3 radical 5 over 8 square inches times 8 triangles, and we do get 3 radical 5, which is 3 squared 9 times 5 is 45, so we get 45 square inches for the total area of the square. So that's been proven as correct. So using the rules of fractions and exponents can simplify the process of expressing non-decimal answers. And there's also rules of exponential values when dealing with other types of squares like cube roots, square roots, fifth roots, etc. So we'll cover multiplying, dividing, etc. radical values into their exponential functions in another video. Thank you for watching this lecture and have a great day.